So let's discuss about HTTP protocol. So as we were discussing back then, uh, like a couple of decades ago, uh, it would have been such a pain if, for suppose, if one software is created for one machine and that machine is entitled to communicate with other machines, but let's say on machine B, if you want to implement the same thing, you have to do from the ground up because that hardware is totally different. But how this TCP/IP model or OSI model is solving that problem? Because here, so we actually logically divided the tasks into several different layers, where each layer takes care of one specific task only. Okay, the physical layer takes care of signaling, which involves like Ethernet cable, okay, and our Wi-Fi radio frequency signals. Data link layer contains each layer has a different protocols. Okay, so what is a protocol? What is a protocol? Protocol is just, let's say, protocol is nothing but a set of rules. Okay, the protocol involves syntax, semantics, and timing. Every protocol involves. Syntax means the set of rules that govern the communication. Okay, so for example, let me give you recently, like let's say that if you are actually, if anybody is in these times, okay, if anybody is uh, throwing a party or something, they have to get some permission and follow the COVID protocols. Okay, so what is here COVID protocol? It is nothing but a set of rules, right? The wear the mask, okay, uh, maintain the social distancing and use the sanitizer. Those are the rules, isn't it? Okay, so uh, so do you understand the protocol here? The using the analogy I explained, set of rules. Okay, so or let's say that sometimes you might heard if you are actually going to meet let's say a top official, government official. Okay, you might heard something like this: our protocol doesn't allow you to meet the minister now, so you have to wait. What does it mean? What does it mean? They have some set of rules. According to those rules, it is not possible for that guest to meet at the time, right? Hmm? So likewise here in communication, that information. So when it comes to that, these protocols, networking protocols, communication protocols, protocol is nothing but just a set of rules that both sender and receiver agree and understand. Okay, and each protocol involves just a syntax, which is just how to structure the message and all, semantics, and what is the meaning of, which explains the meaning of certain uh, terms, and how to interpret the message, and timing is when to send a message and how much delay or to be initiated, and how long to wait to send a next message, all those things related to timing. Okay, so every protocol involves these three things, and end of the day we can simplify this whole complex thing can be simplified and said the protocol is nothing but a set of rules that sender and receiver agree upon and understand. Okay, so likewise we have different protocols in different layers. A data link layer, which involves which is very closest layer to the physical layer, which in here protocol uh, data units are called frames, and we have network layer, which is this is where IP protocol is. Okay, internet protocol, IPv4 and IPv6. Okay, and yeah, other protocols, ICMP. These are all are in this layer, network layer. So in this network layer, which takes care of only routing. Okay, routing means we have sender different routers. Whole internet is made up of different routers. We have sender and receiver here, and the this is a packet switching. The packets can take any path. Okay, this can go. Let's say if you have router here, they can go. They can take any path. Okay, but which path to take is actually, yeah, the way to how to go and which path to take is actually dictated by routing tables. Okay, routing tables, and how routing tables are constructed. There are two types of routing: static and dynamic. Okay, so dynamic is based on dynamic routing protocol, which are there are different routing protocols that are BGP and interior gateway protocols and exterior gateway protocols. Okay, and so OSPF is interior gateway protocol. So this whole thing is out of the context as we're discussing HTTP. But here, okay, so on transport layer, which takes care of transport, okay, which involves just main two protocols, TCP and UDP. Okay, and session protocols, session layer takes care of establishing session. Presentation layer takes care of actually formatting the data for the application layer. Okay, so here the what is this stack? Let's say that application layer we have HTTP protocol. Okay, so and this protocol, this layer works in such a way that application, app, the mostly app, any app, a browser is an app, right? Browser, or like let's say you are using Instagram, all those are apps. The apps tend to work with application layer protocol, and every lower layer protocol provides service to the upper layer, and provides an abstraction to the abstraction and hides unnecessary details, and removing the complexity. Okay, so because see, when you are coding a web application, do you need to worry about this routing? Do you need to worry about this routing protocols? Do you need to worry about frames, data link layer? Do you need to worry about bits, ones and zeros that are put on that are placed onto the wire and they're transferred to the next destination? You don't need to worry about all this lower layer stuff, right? Okay, this whole stuff is actually the more some of the stack is provided by the OS itself, operating system itself. And so the when data comes, like from other end, data comes to the physical layer, which means which has a network card. Okay, that will convert ones and zeros, the signals, 5 volts and 0 volts. Okay, will convert to the ones and zeros and will give it to the data link layer. Data link layer takes those ones and zeros and convert. Here there is a decapsulation and encapsulation happens. So data link layer contains a payload, and the payload is a network layer, PDO of the network layer, which is IPv4, and that will be given to the network layer. Network layer process, and it checks whether it is destined to that machine or not. And if it is destined to that machine, the IP layer contains IP protocol. Okay, the IPv4, which has a header and a payload. Okay, our body contains actual data, and this body contains a TCP again. Okay, and TCP contains a again header and body. This body contains application layer protocol, TCP payload, and that will be given to the application layer. Who does all this stuff? The operating system low level takes care of that, and to the application, it just gives the application data, which is typically the application layer protocol given to the this topest 7th layer, and the application process that protocol. Okay, but here let's say that Because of this, these are actually isolated, right? Each layer takes care of that specific task only. So let's say that this whole stack is fine. Let's say your hardware is not working, your Ethernet cable or Wi-Fi is not working. Okay, all you need to do is actually replace that device. Okay, and without this TCP/IP model, if you are doing the whole protocol as a monolithic, including coding hardware, then you have to do it we would be having a hard time communicating with all these different diverse devices. Okay, so these are all upper layers actually. When, for suppose it is a sender, application layer gives data to the presentation and session layer. This gives data to the transport layer. Transport layer encapsulate that data into the body of its packet and it datagram. Transport layer gives that to the IP layer, network layer, and network layer puts that whole TCP datagram into the body or payload of IPv4 protocol or packet. Okay. Data in application in transport layer, these are called segments. Packets are called in network layer, packets are datagrams. Okay, and data link layer, they are called frames. For suppose in data link layer, the whole data is given and the packet is constructed in data link layer. Okay, so this data link layer gives that to the physical layer. Physical layer converts that data to ones and zeros. Okay, so here in this whole process, if anything is if operating system is changed or different platform is changed, these are just like a socket. They are interconnected. The one layer is giving service to another layer, so that so anyone working in one layer, that you don't have to worry about other layers, low layer stuff. Okay, so anyway, this is just a brief introduction about OSI model, and the HTTP protocol is a application layer protocol, HTTP, and like I said, HTTP. Why it is used? HTTP, which is HTTP protocol, is on top of TCP. Okay, so what protocol it is used? It uses in a transport layer, TCP. Okay, and in network layer, for a routing, what protocol is used? IPv4 or IPv6, it doesn't matter. Okay, okay, so routing is taken care of by network layer. Okay, so it is HTTP, and the other variant is HTTPS. Okay, so HTTPS, which is a secure HTTPS. For this transport layer, we use SSL or TLS. Okay, so where data is encrypted from sender and receiver. Okay, and here for typically you have a browser, right? So what is a browser? Browser is the client. Okay, so client server architecture, how it works? Client server. Okay, so HTTP is a client server architecture. Okay, the way client sends data, so client requests for something, server response. Okay, who initiate the connection? Always client. Okay, so the client is the first person to initiate the connection always. Okay, so here server can have a lot of clients, hundreds of clients requesting a service. Okay, so server should be powerful enough to process the many clients requests. Okay, so here client server architecture, the web browser is what? A client. The web server. Okay, so we have some web server. What is this? A server which process what? A browser's requests. sends the request, server sends the response. Okay, as explained, a client sends the request for the resource, server responds with the resource if it is available, otherwise it sends with the, it replies back with the proper error message saying that that data is not available and so not found, okay, or error something. So but whole idea is a browser. So we can have hundreds of clients, hundreds of browsers, hundreds of users. One user can, so we can count each browser as one user, okay, or one user can use multiple browsers. Anyway, so the multiple clients sends requests and wait for the response and receives the response from the server. Got it? Okay, so this request and response both are interconnected, right? This is a request, they can be, and one more thing, this HTTP is a stateless protocol. Okay, I'll explain. Remember this for the time being, it is a stateless protocol. Okay, so where other protocols maintain the state once connection is established, the where HTTP protocol, how it works, server send the request for the resource. Sorry, client sends the request for the resource, server responds with the resource and disconnects the connection. Okay, so once which is typically browser, the most of the time, sometimes server disconnects the connection or sometimes the browser. Okay, client. But thing is that once you made a request and once you receive the client receives the response, that connection is done. Okay, and if you are making a, so this is how it works. Let me show you. If I have this website, okay, so I have this website, and if I go here IP4 address space, one request is made to the server and response, I got the page and disconnected with the server, done. And if I perform, I'm doing something here, operation, and that is another request, and so this new request will have nothing to do with the previous request. Okay, they are all independent. So this is stateless. Okay, but each request is on top of TCP. Okay, so the first TCP connection is made, and then the over the TCP HTTP protocol is application protocol is used for the communication. Okay, so that is the reason it's stateless. Then you can say then you can ask a question. So if I log in, if all of the requests are independent, how come server know after I log in? If I request a resource, how come server know I am the same person who logged in? Do you get it? What I am trying to ask? Okay, you logged into your Gmail, done, that request is done, you logged in, and the next request opening email received is another request, independent request. Okay, then how come server knows that you are the logged in person, you are the person requesting that email received, if that is independent new request? For that reason we use cookies. Okay, so we use cookies, special key file that is stored in a browser for server to track the state. Okay, so every time request is sent to the server, these cookies are sent on every independent request, so that server checks where so session time is different. Okay, so session time is you can say how it is typically the expiry date for cookies. Okay, so server checks cookies, and based on the cookie it identifies the request. and I'll show you. We'll see that in action in a little while. But do you understand request and response? Okay, and the whole $1,000,000 question is how request is formatted so that server can understand, how response is formatted so that client can understand. Okay, so for that reason I'm using one software called Wireshark. Okay, the Wireshark is a network analyzer and packet stripping software where we can use this software to capture the data on the wire on the network. For suppose like this. So if you have systems, right? Let me show you. Let's say different systems are there. Okay, these are laptops I'm drawing. Okay, and these systems are, this LAN is connected, okay, to router. Okay, this is your office, and this router is connected to another router. Okay, gateway router. And let's say this router is the system. This router can be sometimes a PC, can also be a router. For suppose if I install Wireshark here, okay, so I can capture the all data from this LAN, the users, whoever is browsing, all data I can capture that is going through this router, or okay, that is going out and coming in. Okay, all the data. So this Wireshark is used by network penetration testers, network engineers, for troubleshooting. Okay, and sometimes learning. Okay, and they're used by hackers for snipping. Okay, so as you can see, let me show you one thing. So for suppose, as you can see here, some of the data is being captured. So let me stop this, and I'm stopping and selecting just the Wi-Fi. Start. Okay, so as you can see here, you see so much is going on. So what is this? The real-time traffic from my system, which is going out. Hello? Hello, can you understand? Hello, can you hear me? Hello? 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 Yeah, can you hear me? Hello? Yeah. So, okay, is it fine now? Yeah, is it okay now? Yeah, is it okay now? Shall I continue? Can you hear me? Yeah, can you hear me? Hello? Yeah, now, shall I continue? Yeah, okay. Yeah, okay. Are we good now? Yeah, okay. So anyway, this whole point of showing this is a powerful software that can snip a traffic on the network. Okay, so I'm using this to demonstrate HTTP protocol. Okay, I'm capturing just HTTP only. Okay, HTTP only. For our understanding, I made a small web page, hello learning HTTP. Okay, hypertext transfer protocol, and started a server, okay, on a port 3333. So let me open that localhost 3333. So can you see this page is coming, right? Hello, learning HTTP. Is it working? Hello. Yeah. Can you see? Can you see my screen? Hello. Yeah, yeah. Oh, okay. Is it okay now? Okay. So you can see my screen, right? Yeah. Okay. So see, I made a small web page, and you see that is running on port 3333, and it is working here. So I requested that web page. So as I requested, I'll okay. Let me request that. Let me open that web page, localhost 3333, and I just opened that web page. And if I go back to this Wireshark, that captured two things. Can you see two things here? What are those? First one is a request. Second one is a response. Okay. So go to request, and can you see hypertext transfer protocol? Okay. So if I open this request, and you can see a lot of stuff here. Okay. And the whole thing is that, as you can see, two things you need to how this, see, this is how the request is sent to server. Okay, same can be, we can also see that same thing if we go to network, right? If I reload, if I go to network, click on that, you can see the headers here, request headers. Can you see? Okay, so the same thing we see here, request headers. Okay, so but let me explain just briefly what is this. What is this? This protocol, HTTP protocol, is formatted this way. Okay, HTTP protocol has headers, okay, body. Okay, these two are separated by a new line, slash or slash n. Okay, that we can see here, new line. Okay, okay, so as you can see the separator here, right? Slash r slash n, which is a separator between headers and body, and each header is again separated by slash or slash n. Okay, so this is the structure. What is the structure? A syntax. What is the structure? The whole message, okay, or the content. There are two things we identified here: request, right, and response. Got it? Request is from a client to server. Response is from server to client. So both request, okay, both request, response are structured this way. We have headers, body. What are headers for? These two are separated by slash or slash. What are headers are used for? Headers are used to provide the headers provide the metadata, the mostly, which is the data which is mostly describes about the body. Okay, content in the sense the data that is being sent. Yeah, okay, the mostly about the data and about the server, about the browser. Okay, for suppose one of the header is a user agent. So what that describes, it describes that a user agent is a Chrome running on a Mac OS, right? Okay. So what are these? These are all headers. Those headers not only describe about the data that is being sent in either request or response, but also describes about the environment of the client and the server. Okay. If it is a request, it describes about the client, which is a browser. Okay. If it is a response, which describes about the server. Okay. And also provides the information about metadata about the data that is being sent. And sometimes also headers contains other extra information, such as requesting some special details from the server. Okay. Some special details includes asking about sending a page about language. Okay. Language, or sometimes asking sometimes server asks client to not to catch the response because response updates. For suppose, imagine you are browsing a football score or cricket score, right? What these browsers do, the mostly they catch the response received. Okay. Such that when other requests are made, in fact they use for faster for better performance, these browsers use information from the cache, data stored from the cache. Okay. But when it comes to real-time data such as a football score or stock exchange or the cricket score, we don't want browsers to catch that information because that updates every second or minute. Okay. So that kind of special information, server wants to let the client know this is some special real-time data we don't want you to catch, and that kind of information is also provided in headers. Okay. But altogether, do you understand what headers are provided? Headers are used for the providing, describing environment, providing describing the content. Okay. It is mostly the metadata. Okay. And the headers are separated by slash or slash n, and so we have body. This body contains the actual data that is being sent to server in a request, or from server to client in a response. What would be the body? If it is some server to client, what would be the body? It is a HTML page, right? Okay. If it is server to client, response body contains just a HTML page, isn't it? HTML, CSS, and JavaScript. So that same thing, let me show you. Let me show you in this. Okay. So what is this? This is a response, right? Okay. So let me add something here. Working fine. I just saved. Let me refresh. Okay. And if I go here, so in here itself also I can see in a network tab, I can go to response. What do you see here? The same page, right? Yeah. So which is a body? Okay. Here in response, it is not just showing headers, it is just showing a body. But if you go headers, this is just organize this request response as grouped as a headers and response. So as you can see here, what are those response headers? Okay, in this response headers, can you see here, which is saying a catch control public, and the powered by, which is express, which is describe the who is the server responding there, right? And what is the content type? Content type, which describes the what kind of content that server is sending in a body, which is a text HTML. It will be application JavaScript if it is a JavaScript. Got it? And describing a length of the content, length of the body. Now do you understand? It should make sense. The all headers are actually the metadata, right? Data about data, describing the body, and describing server environment or client environment. And same thing, let's go to our this and check this. This is the last one, right? After modified, right? So if I go here, can you see here the response? Okay, if I double click, it should make sense. Can you see here? So we have headers, right? Okay, hypertext transfer protocol. Okay, here we have headers, and last one is, oh, what is the separator between header and body, which is a slash or slash n, new line. Okay, which means a new line. After a new line, what do we have? We have body, and that body is described here. Can you see? Okay, and this is what server sent to the browser. Okay, so as you can see, server sent a 311 so that browser understands, okay, this much number of bytes, 311 bytes I need to download. Okay, and what kind of data, which is test HTML, and as you can see here, this is a preview, this is a response, which is a body. Got it? Right, do you have any questions in this? Okay, which is simple. We have headers in a response. If we take a response, we have headers and a new line, and we have body. This body is just a HTML page, right? Okay, and what is happening? Browser actually understood the kind of content according to the headers and took the body and rendered that body as a HTML, as you can see here. Got it? Right? Any questions? No. Okay. And here we have different types of, and see, let me show you in a browser. So what is this? There are headers in both request and response. And yeah, request contains a first line, which is describes about which is called request line, which describes request line, which describes the kind of request, what request it is, and what the protocol it is using. At the moment here it is HTTP 1.1 protocol. Okay, and all other are actually headers regarding that request. And the response also contains, of course, response headers, but the first line is very special, which is called response line. What it describes, again, the protocol and the status. 200. Okay, this describes there are actually status codes. Okay, there are different types of status codes. Okay, so 100, all status codes from 100 to 199 are for informational purpose. Okay, which include actually initiating connection, okay, switching protocol as described here, and any status code from 200 to 299, which means that the request process successful. Okay, request is successfully processed by server, and all if this response line contains this response. Where is this one? Yeah, this response line contains, for suppose, 300 to 399. What does it mean? It means that redirect. It means that server didn't find any resource that you are looking, but it is trying to forward your request or redirecting. Got it? Is it confusing? Okay. For suppose you are see the most of the browsers, if you try HTTP, that will automatically redirect you to HTTPS. Okay, the with the response code 302 or 302 302 or 301. Okay, the where 301, which is moved permanently, or 302, okay, temporary redirect. Okay, another one is client error. Any request from 400 to 499, so which is a client error. For suppose a client is requesting something not available on server, which is a 404 not found. Okay, which is a client error, client needs to fix. Any request from 500 to any response code, which is 500 to 599, which is a server error, where server supposed to process that request, but because of some reason, code error or exception, server is not able to process. Okay, the in reality the server errors should not happen. Okay, so this the most of the time what you get 200, okay, which means the request processed and we got the response. And the for the bad request, 400 bad request, means that server didn't understand the request client sent. Okay, and 401 is unauthorized. Server is expecting to authorize yourself with credentials. 403 is forbidden, which means you don't have access to the resource you are trying to access. 404 is not found. Okay, there are uh, other error codes here as well, and any error codes that are not standard we can use for our purpose. Okay, see, as you can see here, from 400 to 499 total, almost we have 100 error codes, right? But all 100 error codes are not predefined, standardized. So anything that is not used, if you are creating yourself, developing your own a protocol, you can actually create your own unused error code to actually make it more descriptive about the situation or kind of error. And 500 is the most common if there is an error processing request, which is 500 internal error. 501 means not implemented. The client requested, of course, that is a valid resource, but not yet implemented on server. The 502 bad gateway means that is happens when there is a proxy or a load balancer in between that is not trying to fetch the response for the client. And there are other requests, other error codes, explore. And these are error codes. And so we got 200, okay, which means our request is success, response is success. And here is the response body. Okay, the basically these two headers and body come together, right? But here it is just showing for our understanding the past and displayed in just two different tabs, right? Do you understand? Okay, so these are response headers. Now the what is this get? See, this is called HTTP web, okay, or a request method. Okay, so that is called yes, 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 that is called, yeah, yes, 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 you are right. you are right. The post, we can send a data to server in a body, whereas get, we don't, we it is just a use it to fetch the resource, where we, yeah, fetch the resource through request, and we can't send any data in a body, okay. So get is without body, and where post is with a body. And what are the what are these called? HTTP methods or HTTP webs, okay. And there are bunch of them. What are those? Get, okay, head, post, put, delete, and options, okay. And there are patch and connect, and there is another one, trace, okay. So these are the last two we don't use much, okay. So they are very rarely used, okay. So last two. And so these are actually used the REST protocol, REST API, okay, used in REST API. REST API stands for Representational State Transfer Protocol, and which actually promotes using a proper web or a proper HTTP method that is created for. So where get is used to get the response, head is used to both get and head are identical, okay. Where head is just used for informational, to retrieve just the headers, to retrieve the head, just metadata. Why these both are identical? Because they don't have body, okay. So like if you say as described, request contains headers, right? Headers, body, the way, both request and response, okay. But this head, get and head doesn't contain body, with just headers, okay. And post is used to create the resource. Post method is used typically when we ask a server to create a resource. For suppose you are creating a new user or new task, new ticket, okay, new, okay. So in such a case, a post is used to create the resource, and okay, and where body contains the data we are actually asking server to create, and put is used to update, okay. And whereas update or replace, delete used when we ask a request, when we ask when we wanted to when we want server to delete certain resource, we, in such a case, we use what? Delete request, delete method or web. The options is used for mostly when cross origin resource sharing. So when browsers use for to fetch some extra information regarding other requests, following requests, whether they can make us certain requests or not. But the mostly options is also like a head, okay, the which doesn't contain body, where which comes from basically uh, uh, which where browser asks whether to make a sorry, let me rephrase, where browser asks whether about certain resource, certain request, whether it can perform certain requests or not, okay. So mostly this is about information asking, this is made to get some information from the server, Okay. So which is mostly describe the communication. Got it? The okay. So and patch is used for the partial update. Okay. So you have a for certain update for suppose you have a user or customer on a server. Customer is a resource, and through request using put you can update or replace, but using patch you can partially update that resource. Okay, so these are all except the get head, all others support the body. Okay, and connect is just advanced connect and trace, or which is used for debugging. Connect is used to when making a connection. Okay, so that tunnel or a connection, the we that is that HTTP header, HTTP method is used, but we don't come across these two often. These are main. Okay, the first suppose when you are submitting a form, which request, which post, which HTTP web do you use when you are submitting a form? Post, right? When you fill in the form and when you submit, you are using post. Let me show you that in action. Okay, so I will go here and let me go to Google. Okay, let me sign up. Signing. Okay, and or sign up, create account. Just let me clear it off and next. Uh, Here, let me add a new header method. Okay, I just added, right click and added. See, these are all things we can enable. Okay, protocol. So I added a protocol. Where is this? Yeah. Okay, so we can enable them. Okay, but main thing is method. So when I created that, which yeah, post request is met. Okay, so and as you can see, these are request headers, response headers, and response headers. These are response headers. Who is the server? Content type, as you can see, application JSON. Why is it application JSON? Because as you can see, come here response, which is a JSON, right? Content type, describe the content, and content encoding, gzip, which describes that, see, the server is sending a response, but which is compressed. Okay, and saying no catch and cookies here. You see, the asking response, asking server to set this cookie. Okay, and here these are response, but what a requested does, you see again, user agent is there. Can you see here when you scroll it, when I scroll it, can you see all requested does? The refer is there. Refer means from which the link we came to this uh, sign up account, right? And we have here content type, the type of content browser is sending, which is sending application form data URL encoded. As you can see, view source, this is what server is sending, sorry, client is sending, browser is sending. Okay, and user agent is here, which is about the browser. And if we scroll down, Scroll down. As you can see here, the all details I entered here, isn't it? All details under I enters and other information, which is basically what? This is a body. Got it? Yeah. This is what are headers? What are request headers here? These are the request headers, and request body is here. Farm data. Okay. And same thing we can see in a Wireshark, but that is not possible here. Why? Because this is secure connection. Okay. So, and that is about the request response and request method. As you can see, we have a certain tool, HTTP headers. So let's say we have GitHub, just hit enter, and with just this tool just simply sends the request and shows the all headers received. Okay, these are what? Response headers. Okay, let me show you one thing. Let me request http get kt.com, and you will see redirects here also. Can you see here? Why do you see both here? Why? Because like I said, first one, what is first one? 301. We just learned about a code. Anything just that is from 300 to 399, which means a redirect. Yes. Server responded with 301. It said that your resource is available but not at this place. See your resources here at this location. So we made another request to that location, and we got the 200. Okay, and here are the response. And from server, what it describes, the Apache is the server, web server. Okay, so this is about request response, and we have different HTTP webs. In the further sessions, we will explore about creating REST APIs and how to work with these different HTTP webs. But I hope you understand so far about the HTTP protocol. So any questions?